Hi, in this video we're going to have a look at question 2 in the recent Year 10 mock exam for GCSE Electronics. The class average was 73% for question 2, so not too bad, not quite as good as question 1. Okay, so we're looking at electronic subsystems here, and typically we can classify them as input, processor, or output. In this paper they call them sensing subsystems, so sensing, that's input, sensing, it senses. And then process and then output. So not very different, just be familiar with that. Sometimes I might call them input, here it might be called sensing. So we got some subsystems and they're expecting you to fill out a table with them. So let's look for some easy ones to start off with. A switch, most people are going to be aware that's going to be the input. That's the thing that you're going to press on input. Converts your physical action of a switch press into a signal. So we've got the switch unit. I'm just going to write switch there. I don't think there's going to be any confusion. And then let's have a look for outputs, because outputs are generally quite easy to see as well. And lamp, it's a transducer. A transducer just converts one type of energy to another, in this case electrical into light, and also a little bit of heat as well. So we've done the lamp, and then it gets a little bit more tricky. Shouldn't be too difficult. This one causes a lot of problems to people, though, if you just didn't revise it. A solenoid is the sort of thing that might be an actuator for a lock, like throwing a bolt, or the locking mechanism. In other words, let's just quickly. This won't be a realistic drawing of it, but let's have a battery. Let's have a switch, and then let's have a coil, okay, an electromagnet like that. So when I press the switch, then it's going to energize the coil, and you're going to make that into an electromagnet. Let's stick a permanent magnet down there, and I think you probably know that when the coil is energized, then the magnet might go one way or the other, and then maybe have some sort of spring for a return or something like that. So that's a very basic sort of solenoid unit there, and as I say, it could be used as some sort of actuator, some sort of door locking mechanism, or there's lots of other applications besides. But it's definitely an output, because the output is the mechanical movement. So that's the solenoid. Get rid of that one. It only leaves us two left, the latch and the Nand gate. So they must be signal processing. Hopefully you understand that. NAND gates, they are taking logic inputs, and then they're doing some processing, and then have a logic output, which is then going to go to the next subsystem. They wouldn't be, if you look at a NAND gate, you can't actually see an output. They're not an output subsystem. So let's put NAND there, and then a latch. A latch is probably or possibly going to confuse a few people. We're not talking about like a door latch, something physical. We're talking about maybe, let's say we have a momentary switch, that sort of thing, and then you press it momentarily, in other words, just like for a brief moment, and then you want, say, a light to stay on. You're going to need some sort of processing system which holds that value. So you press it, it stays on until maybe you press a stop switch or something like that. So, or reset switch. So that's a latch. The latch in itself, if a latch is latched on, you won't actually see anything from the latch itself. It's not like got an output that you'll be able to visualize, like a light bulb coming on or anything like that. That's likely signal processing, likely to connect to, say, an output transducer, which is then going to connect to an output system like a lamp. Right, okay, so we've done all those. Hopefully that's clear. Next one is a flashing light system for roadworks, I think. Yep, roadworks on a motorway. And we're doing a similar but slightly different project in Year 10 at the moment, just as a practice. And we've got a pulse generator, and so that's going to be outputting a stream of on-offs, like so. Sorry, just off the screen there. I have to look down at the paper and also look up at my screen in front of me. So that's a pulse generator, and we only actually want the lamp to be flashing when on pulses and when it's dark, because it says that when it gets dark So we're also going to need a light sensing unit. There we go. Okay, I'll just write LSU. I mean, really, you should write light sensing unit. Let's just speed up here. So when the light sensing unit says it's dark and the pulse is on a logic high, so we need a logical and there. Okay, which is going to be there. Okay, don't draw the and symbol. You know, write and. Now an AND gate can't drive a lamp unit directly. They can't source enough current to do so, or typically can't source enough current. So you need something which is going to drive that output transducer. So we need an output. We need a transducer driver. And if you look through here, I don't see anything called transducer driver, which sometimes they do have. So you're looking for either a transistor or a MOSFET. Okay, not the thyristor. We'll talk about that another time. But a transistor or MOSFET, there is a MOSFET there, and yeah. So if they also had a transistor, you know, either of them would be okay. Actually, the MOSFET has some slight advantages, but as a switch. But yeah, they make it simple for you. It's just MOSFET. The next one is the one which probably caused the most problems with this question. And so we've got this pulse generator, this thing which does the high, the low, the high, the low. And it's doing the highs for 3 times the duration of the lows. Okay, so that's the mark, that's the space. So this 3-to-1 ratio. In other words, if I just quickly sketch this out, if this is time and it goes on for a period and then off for a period and then like that, okay? So this is 3 times the time of this, okay? Now, it also says that it's 2 hertz, and 2 hertz, what that means is 2 cycles per second, okay? So in other words, if there's 2 cycles per second, that's 1 complete cycle, and then that is going to be another complete cycle. So that's going to be 1 whole second there. Now they don't actually write any numbers on this scale, so we're going to need to add a scale, and that caused lots of people a problem. Didn't actually do that. So let's do that now. Now you could, if you wanted, you could have like a tiny little scale, and you could have, you could maybe, for example, you might decide that you want to use like 3 squares and then 1 square low, and then 3 squares high, and then 1 square low. You could do it like that. Nothing wrong with that. I'm not going to do it like that. Oh, and also the vertical axis, they don't tell you what the output voltage is, so you can go as high as you like. So what I'm going to do, and hopefully this is going to make some sense to you, I'm going to say that 5 of these squares, I'm going to do so 5, 10, 15. So I'm going to have 15 small squares, and then I can have 5 small squares. In other words, I'm going to have 15, 5, or 3, 2, 1. Okay. Now you don't have to do it like that, and I'll just do it, like this. You would probably be better to do it neatly with a ruler, and do make sure that it's visible. I had a couple of students draw this probably really carefully with a ruler and a black pen, and then I couldn't actually see the writing on it. So we got 15 squares high, that's the mark, and then we got 5 low, so that's 1 cycle, in other words. So that they don't actually ask you to annotate the cycle, but let's call that cycle 1 just to add some clarity to it. And let's go for the next time high, so 5, 10, 15. So there we go. All right, so that's the mark. So once again, that's the mark, the time high, and then we've got time low. So that's cycle 2. Okay, like I say, they don't actually ask you to label the cycles, but I think that's going to be useful. Right. Okay. So that's 2 hertz, 2 cycles per second. So let's imagine that is like second 1. Then by the time we get to the end of the second cycle, that's going to be at second 2. Okay. I mean, it doesn't matter. I mean, that could be 100 seconds, and then that could be 101 seconds, so long as the time difference between those two is 1 second. That's not a problem. Draw 2 cycles. I've done it. Clearly label the mark and space. Haven't done that yet. So let's annotate that. So I'm trying to look over a webcam as well. So yeah, sometimes I'm probably wondering what I'm doing. So that's the mark. That part there is, I just rotate it around, that part there is the space. Okay, so we've got the mark and space, and then we've got the mark and space, but I don't think we need to do it twice so far. So we've done that, and then add a suitable scale. Well, I've done the scale because I've got 1 second and then 2, so that's 1. But as I say, it could be, you could also, you could compress all this in if you wanted. That's no problem so long as your scale is appropriate. That's worth 3 marks. I will record another video for the next question now.